Hello everyone! So today we'll be learning how to graph linear equations, so let's get started. Alright, so before we begin graphing equations, we first have to know some basics. We have to know what is a linear equation. A linear equation is formed in this way. This form is called y-intercept form. It's y equals mx plus b, and I'll go over what each variable means in a second. A linear equation's graph will be, it's in the name, linear. So this right here, because this graph is a line, that means that this graph's equation is a linear equation. It means that it is in this form. On the other hand, when an equation is not linear, it will not have a line as its graph. Its graph will be not a line. It's gonna be curved, it's gonna look like this, or a squiggly line. It's just not gonna be a line. For example, this right here is not a linear graph, and its equation is therefore not a linear equation, because it's called a parabola, and it's evidently not a line. So this is how a linear graph should look like, and this is how a nonlinear graph would look like. Alright, so as I said before, when a graph is linear, when a graph is a line, the equation will be in this form. Y is equal to mx plus b. This is an equation that's very important to memorize. Y equals mx plus b, y equals mx plus b, and y equals mx plus b. Remember that. So this y represents the output, is equal to m, which is called the slope. And the slope is how steep the line is. And you figure out a slope based on a line by looking at its coordinates. Now in this case, there are no coordinates, but it's important to remember that the slope is equal to rise over run. So this is your rise, and this is your run. Your rise is vertical, the run is horizontal. Then the x is just your input, plus b. And b is called the y-intercept. The y-intercept has coordinates of 0, b. For instance, this graph's y-intercept is located right here. The y-intercept is the point where the line crosses the y-axis. So this is the x-axis and this is the y-axis. B is where the line crosses the y-axis. So it would be located right here, and this would be your y-intercept. And I also want to mention that this too has a slope, and it also has a y-intercept. The y-intercept would be located right here at this point, because this is where the graph crosses the y-axis. But the difference is that its slope is constantly changing. Its slope isn't the same all around. Whereas here, a line has a constant slope. So the slope is always the same no matter where you are in this line. Right here, it's changing. So as an overview, a linear equation is written in slope-intercept form. Y is equal to m, the slope, x, the input, plus b, the y-intercept, and it looks like this. A linear equation's graph is a line. This would be a nonlinear equation and a nonlinear graph, because this is not a line. Alright, so our first problem is negative x plus y is equal to 5, and we have to graph the equation. And I left this up here because this is very important. Alright, so our first step is to get this equation into slope-intercept form. So we have to isolate the y. What is happening to y? It is being subtracted by x. Because if we were to rewrite this, it would be y minus x is equal to 5. X is being subtracted to y, so we have to do the opposite, which is addition. So we have to add x on both sides. Y equals x plus 5. Alright, so now our equation is in slope-intercept form. Y is equal to x plus m. You might be wondering, so what is the slope? What is m? Well, m is just 1. We usually don't write that 1 because it's just known that whenever x is by itself, really there's an imaginary 1 there. Alright, so now that we have our equation in slope-intercept form, now we can graph. And the first step for graphing is that we have to plot our y-intercept. That is what we do first. So our y-intercept is 5. And remember, the coordinate for the y-intercept is 0, b. So it's going to be 0, what is b? B is 5, because 5 is the y-intercept. So we plot this. X is 0, so we're not going to move. The y-intercept is 5, so we go 5 up. 1, 2, 3, 4, 5. So this is our first point. This is the y-intercept. And we could write its coordinates, 0, 5. When you're graphing a linear equation, you need at least 2 points in order to actually graph it. So we still need 1 more point. And we will find that other point by using the slope. So when our slope isn't already in a fraction form, we have to make it into a fraction. So what is 1 as a fraction? 1 as a fraction is just 1 over 1, because 1 over 1 is equal to 1. So 1 over 1 is our slope. 1 is also our slope, but writing it in a fraction just helps us graph it. So 1 over 1. So from this point, we're going to go 1 up and 1 to the right, because we are rising 1 unit. So we're going to rise up 1. And we're running to the left, because left is positive and up is also positive. We're running to the left 1. So this is where our next point will be. And from these 2 points, you can already draw your line. And this is our line. Next problem. Our next problem is y minus 6 is equal to 1/2 x, or 1/2 times x. Our first step is to get this equation into slope-intercept form. So we have to isolate the variable. What is happening to the variable? It's being subtracted by 6. So we have to do the opposite, which is to add 6. We isolate y is equal to 1/2 times x plus 6. And this is our equation in slope-intercept form. The slope is 1/2. And the y-intercept is 6. Now let's graph. First have to plot the y-intercept. So the y-intercept is 6, which means that the coordinate is 0, 6. So 0, 1, 2, 3, 4, 5, 6. This is our first point. So since our slope is 1/2, we have to rise 1 unit and run 2 units. So from this point, we rise 1, right 2. So right there. And this coordinate would be 2, 7. And now we can draw our line. And this is how our graph would look like. Next problem. Alright, our next problem is 4x plus y is equal to 0. We have to get this equation into slope-intercept form. And to do that, we have to isolate y. So we have to get 4x on the other side of the equation. So 4x is being added to y, so we're going to subtract 4x. Subtract 4x on both sides. We're left with y is equal to 0 minus 4x is just negative 4x. And this is our equation in slope-intercept form. You may be asking, where is the y-intercept? Well, we can imagine that the y-intercept is just plus 0. So our y-intercept is 0, what is b? 0. So whenever you don't see any constant in the linear equation, that means that the y-intercept is just 0, 0. Now that we have our slope-intercept equation, we can graph it. So we have to plot the y-intercept. So the y-intercept is at 0, 0. We find the next point by turning negative 4 into a fraction. So we can do negative 4 over 1, because negative 4 over 1 is just negative 4. Whenever your slope is not already as a fraction, then you always just put a 1 over it. So we're gonna rise, or in this case, since it's a negative, we go down. So we're gonna rise, but we're actually gonna drop 4 units and run 1 unit. So let's drop 4 units. So we're gonna go 1, 2, 3, 4 and run 1. So we went -4, then 1. And we could draw our line right here, but I'm just gonna show you how to find a next coordinate, and you could just drop down 4 and go to the right 1 again. But let's do the opposite. So since it's saying -4, we're gonna go up 4. So 1, 2, 3, 4. And instead of going to the right 1, we're gonna go to the left 1. So this would be our other point. And going up 4 is okay, because if we're going up 4 and we're going to the left 1, it would be -1. So 4 over -1 is just -4, and -4 over -1 is just -4. So going up 4 and left 1 is okay. And this would be our line. Then we can find the coordinates. So the y-intercept was just 0, 0. Then our next point is 1, comma, -1, 2, 3, 4, -4. And this coordinate would be -1 and then up 4. So 1, 4. And this is our linear graph. Alright, so I hope this video helped, and as always, I will see you next time. Bye!